Hello, today I'll be reviewing some of the content for the upcoming test. I'm going to start with the algebraic fractions, complex fractions, and I'll do some radical questions as well. So starting off with this question here, the first thing I'd want to do is invert and multiply this expression. So we are going to flip the numerator with the denominator and then switch the division sign to a multiplication sign. And before we multiply these out, it's always a good idea to check for factors. If you look at this term right here, x squared minus 36, you may notice that that's a perfect trinomial. So, or sorry, not a perfect trinomial, a perfect square. So we can factor that out as x plus 6 times x minus 6, because 6 is the square root of 36. And then the denominator here, it can also be factored. Both 8 and 24 are divisible by 8, so that leaves us with 8 times x plus 3 times this top term here. We have x squared minus x minus 12. That is a simple trinomial, so we can either factor that by finding two numbers that multiply to negative 12. So we have 1 and 12, 2 and 6, 3 and 4. And that would give us negative 4 and 3 that multiply to negative 12 and add to negative 1. But we can also pull out the calculator. I've already done it here. But if you go hit mode, number 4 for equation, number 2 for quadratic, and then enter 1 for the coefficient of the x squared, negative 1 for the b value, which is negative x, which is negative 1, and finally negative 12 for the c value, and hit equals. It'll give us x equals 4 and negative 3. So that means we have x minus 4, then x plus 3 over 4x minus 24, but we can also factor that as well. So we have 4x minus 6. Now, before we multiply those together, we can simplify some terms. So we have our x minus 6's that we can cross out because they're in both the numerator and denominator. Then we have the x plus 3 in both the numerator and denominator. And now we are ready to multiply these. So we have our x plus 6 times x minus 4. And then 8 times 4 is 32. And some teachers would be happy with this answer. Just in case, I would multiply this out. So we'd have x squared, x times x, plus 6x minus 4x. So that'll be plus 2x. Then plus 6 times negative 4, so minus 24 over 32. And that would be your final answer. All right, next up we have question number 2. We want to simplify this expression, and we're going to be doing this by finding the lowest common denominator and then adding the terms together. So the first thing you want to notice is that there's a perfect square in the denominator of the first term. So we're going to expand that out. So we have x squared minus 9. So that would give us x plus 3 times x minus 3 plus 4 over x minus 3 minus 3 over x plus 3. And now what we want to do is get a common denominator for all these terms. So in order to get a common denominator, we are going to multiply this 4 and 3 by the corresponding denominator. So we're times this by x plus 3 over x plus 3, times this one by x minus 3 over x minus 3. And expand this out. And now that all these terms have the same denominator, we can put them all the same 4 times x, same division. So now we'll have plus 4 times minus 2 plus 12 plus minus 3x 4x plus 9 x plus 3 over minus 3x plus 3 x minus 3 times x minus 3. Now we just collect like terms.
Over
I like to mark them with a little
x plus
slash.
3
times
3 plus 4
minus 3. So that gives us 4x. Then we have negative 2 plus 12 is 10. 10 plus 9 is 19. Over x plus 3 times x minus 3. And then in most cases, that would be a good final answer. Some teachers would like you to simplify the bottom. So x plus 3 times x minus 3, that was our difference of squares. So that'll give us x squared minus 9 for our final answer. Okay. Next up, we have question number 3. Just change my color. So for this question, we want to solve for x. So when we're given an equation like this, where we have fractions in multiple terms, ideally, the easiest thing you could do is multiply all these terms by a common denominator. So a common denominator between all these, we have 4, 7, 11's over 1, and 2. So 4 times 7 is 28. You could times that by 2, but that's not necessary because 28 is already divisible by 2. So what we can do is multiply each of these terms by 28. So I'm going to write that out as 28 times 7x plus 8 over 4 plus 28 times 9 over 7 equals 11 times 28 minus 28 times 3x over 2. And now you can just put that into your calculator. 28 divided by 4, that gives us 7. Divided by 7 times 9 would be 36. Equals 11 times 28. Gotta pull up the calculator for that one. Equals 308 minus 28. Let's do this all in one step. So negative 28 times 3 divided by 2 is negative 42x. Now we just have to expand out this bracket. So we have 7 times 7 gets us 49x plus 56 plus 36 equals minus 42x. Now we can add the 56 plus 36. Gives us 92. Now I'm just going to add over the 42x to the other side. So we have 91x plus 92 equals 308. And now we'll subtract 92. So 91x equals 308 minus 92. Then divide both sides by 91. 2.374. All right, next up we have this radical question here. So we have 7x plus 4 root x squared. So what I like to do, I like to just rewrite it as two binomials. And then you just have to remember to multiply each term by each other. So we have 7x times 7x gives us 49x squared. Now we have 7x plus 4 root x plus 28x root x. Then we have 4 root x times 7x, so we'll have another 28 another 28 x square root of x. And then finally 4 root x times 4 root x will give us 16x. One way to think about multiplying these two square roots together is the square root of x. You could also write it as x to the power of 1/2. And so if you're multiplying x to the power of 1/2 by another x to the power of 1/2, your exponent rules tell you that you add exponents. So x to 1/2 plus 1/2 would equal x to the power of 1. So that's just another way of thinking about it. Okay, now we will just collect some like terms here. So 49 x squared plus we have 56 x root x plus 16x. And some teachers would be happy with this final answer. I'm just going to factor out an x from these terms. And that would be your final answer. Right, and then finally, our last example of today is over here. I'm just going to move that. Let's move it up here. So we have two cube roots multiplied together. So the first thing I would do is see if is there any cube roots or any perfect cubes within these brackets. So 81 is does have 27 as a factor, and 27 is 3 cubed. So can write that out as cube root of 27 times 3. And then we have x to the power of 5th. We can factor out a perfect cube of that. That would be x cubed. And then we'd be left with x squared. So times x cubed times x squared. And the reason I'm putting this, I'm breaking all these terms apart is so that we could take out these perfect cubes out of the equation. Now, next up, we have 16 x to the power of 4. So 16 is a product of 8 and 2. And 2 to the power of 3 equals 8. So we can write 8 times 2. And then again, we can take out x cubed. And we'll be left with x there. And now we can take out these, we can bring these terms outside of the cube root. So in order to do that, we take out this 27. We just have to take the cube root of it out. So we will have 3 times cube. We can take this x cubed out as well. The cube root of that would be x. So we'll have 3x, and we'll be left with 3x times 3x squared times this next term here. We can take the cube root of that 8. Let's give myself a bit more room here. Cube root of 8 is 2. And then we can also take the cube root of this x cubed as well. So we'll have 2x, and we will be left with, don't forget the cube root there. We'll be left with 2x. And when we're multiplying two roots that are to the same exponent, we can multiply the front two terms and combine the radical. So 3x times 2x will give us 6x squared. And then we'll have 3x squared times 2x, which equals 6x cubed. And now we have x cubed under the cube root, and we can take that out as well. So we'll have 6x squared times x times root of 6, which will give us our final answer of 6x cubed times the square root of 6. All right, that concludes this first video I'm making for the review. I should be able to make 1 or 2 more videos. I'll keep you posted in the Teams group. If you have any questions, feel free to message me on Teams or D2L, and I'll see you guys later.